YouTube creators, if no.
All right, I just cut that off. Give me a second. Getting myself sorted. Camera on. Hello, everyone. How are you going? I hope you've had a good Monday after you were so cooked yesterday. And what I've decided is I started already recording the rest of that lecture program so that you can watch it later. Enjoy your flex week. In case you miss having a lecture too much, you can watch that. And today we're going to push on with all the content that we have to do, of which I wanted to cover a little bit before we go on flex week next week, which is always an exciting week. So the things that I want to do today, it's going to be a big day, but hopefully it's going to, thank you. But hopefully it's not going to be too bad, because I think the enum in a struct in an array of arrays was starting to like really cook you up. So hopefully this will give a little bit of a break and a reset for your brain before we go back. Okay, so today I hope to do command line arguments, which is super fun. Pointers, which everyone says are not fun, but they are fun, but not at first. At first, they're not that fun. So it's a little bit of this, a little bit of that. And then we're going to talk a little bit more about memory and how we can, be really greedy and take more memory and decide that we want some memory, as opposed to just letting the compiler decide how much memory to allocate us. This will allow us to take some memory at runtime when the program is running as well. So yay. Okay, excellent. Let's start, not let's keep going. Okay, so yay, and I thought, oh, maybe I'll do multi-file projects, but we're going to do them after the break. Oh, I don't want to do, I'm sorry, wrong slides. I wanted to do these slides. I've got two sets of slides going because I want to do two things. Okay, so far we've had an int main void, which means that our main has been running with no input, right? So it's just been, we've been compiling it, and then we've just run the program as it is. We haven't given it any input on the command line. So command line arguments are these wonderful things that allow us to give some input into the program at the very beginning. And actually, in fact, you've already been doing that when you've been using DCC. So when you do your DCC and then when you kind of run the thing, you kind of already do that because you give multiple commands to DCC to do something with, right? So you're kind of doing it already. So what they allow us to do is at the time that we start running the program, we can actually give it something. So then when we run our program, we can actually give it some arguments to do something with. So this one is exciting. So in order to do that and in order to allow us to happen, for that to happen, is instead of writing void in our brackets as our input, what we now do is we do int argc char star argv. So in about 30 minutes, you will know what that star means because that star is the beginning of pointers. I'm just going to say that denotes a pointer value, and we will talk more about that. For now, just remember that's the way it kind of goes. And think of argv here as an array, right? So argc is the number of arguments or argument count, okay? So it tells you how many things are on that command line, including the name of the program. So including that // whatever you put there, that's the first one, and then it counts them up. And then argv is the array of the strings that you put on the command line. So it is the array of all the different things that are separated by a space. Okay, so what does it look like? Let me show you what it looks like in action. Yay! Oh God, see, this is why I was recording the video, then I needed a break for lunch, and that's when I stopped recording the video. So it's half done and half not done. So I can do this. I can do this. I can like think, and I can be like a human person that is thinking. Okay, so this program, let's see if it's visible to you. No, it's not, so let me give you visibility to it. We will do cla.c first, command line arguments. So, sorry. Okay, so that was aspirational, it's not a rehash, but what is going on is we're going to learn how it works. So we have our include, that's all normal as is. Normally this would be void, but in order to do command line arguments, we're now going to use int argc char star argv. Actually, can you see the screen? Can everyone? No, not here. Let me. Oh goodness, I am not having a field day. That's for sure. I'm sorry. 2 seconds. Okay, I'm back. Okay, so argc is going to count up the number of arguments that you have on your command line. The star is going to be what a pointer is. Okay, so you will learn about what that star actually means in about 30 minutes. And then argv is the array of the strings that it's taking off the command line. So I'll show you what it means. It's much better, it's much easier to understand when you see it in action. So if we have a printf statement that says there are blah blah command line arguments in this program, argc is the thing that counts that up. So I'm going to use argc to substitute for this %d. And then I'm going to loop through and I'm going to print out every single command line argument, okay? So what I'm going to do is I'm going to loop through this array that I'm given here, and I'm going to print out each and every single one of the command line arguments that is listed on the command line, okay? So it's really all the same in that I'm going to do a loop, okay? So if I do a loop, I'm going to do a for loop, and I'm going to do it the same, int I is equal to 0. Now, if argc is the thing that counts up how many arguments there are on the command line, that means that I'm going to keep looping until my argc is met. That's the thing that counts up how many things there are on the command line. And I'm going to increase my index each time that I go through one. And then to demonstrate what's going on, I'm going to print it out. Argument blah is blah, and it's always a string, okay? So we will learn how to convert that to numbers as well. There is a way to do it. So we're going to do I, and we're going to do argv at index I, okay? So argv is an array of all the arguments, and then argc is the number of how many arguments there are. So for example, let's compile it, and I'm going to give it a name now. So I'm going to call it CLA, okay? So that's compiled. So now, okay, if I run this program, okay, this here is the name of the program, and it's going to be one argument, okay? One argument, so the first string is going to be the name of the program. So the first string is CLA. So now I'm going to add some more strings just to demonstrate to you what it's doing, okay? And we all love COMP1511, exclamation mark. Okay, so let's see what's going on. All right, and let's run it. So there are 5 command line arguments in this program. Let's count them up. 1, 2, 3, 4, and 5. So the different ones are separated by space. So the space is what gives you the understanding of the next thing is coming. The program name is always the very first index. So at argv0, we've got our program name, which is .cla. So argument 0 is .cla. Then we've got argument 1. So whatever is sitting at argv1 is the first string, and the first string is we. At argument 2 or at index 2, we've got all, so that's the second string. At argument 3 or at index 3, we've got love. And at index 4, we've got our COMP1511 exclamation mark. Okay, so it is a string of, yes. So it's a string of strings, and there is more to it. You can even separate things by character in each of those strings. Yeah, oh my lord is probably the correct response to this. But it's actually really fun, right? And so this is not going to be like a huge part of 1511, but you will need it in 1521. So I do cover it a little bit so that you understand what's going on when you move on to the next course as well. Also, to give you an understanding that it's not always void here. Sometimes it's going to be something else. Sometimes we take in other commands. So when we do our compilation, we actually take in a whole bunch of commands, right? And there is lots of things that actually matter. So this counts because it's the very first argument on the command line. Okay, so you've got an array of strings and the strings are separated by the space between each one of them. Yep. Okay, so that's right. You haven't used scanf or fgets. You don't need to, because you're taking your command lines you're taking the inputs from the command line. So if you note, when I run so I'll compile it, and when I run it, I've taken all of my inputs from the command line straight away. So I'm operating now knowing what those arguments are. So I don't need to use scanf or I don't need to use fgets. I'm just taking it straight from the command line. When I run my program, I also give it a number of arguments to work with. In this case, they're not really doing anything, but that's how it works, okay? Would it still run if you rename the main function to something else? No, because I always need to have a main function, if that's what you mean. What else? What code is allowing me to take it from the command line? This over here is allowing me to take it from the command line. So this inside int main is what tells it that you will take arguments from the command line, okay? This is saying, this is the standard, and it's basically saying count up the number of arguments. So that's this bit here. This counts how many arguments I give it, and this takes in the arguments. What an excellent question. What if you want to take in ints? You can do some magic things. So for example, okay, if you were to take, if I'm going to do ints, okay, I'll do 7, 8, 9, 10. Does that sound okay? What you'll see happen is that it will process these, okay, but it only sees these as strings right now. They are not ints, so you would not be able to actually do any mathematics or anything like that with it, okay? So right now, not much happening. You can only do it, it's only available to you as strings. You cannot actually add them up or do anything like that. So I'll demonstrate it for you. So if I have this, and then here I'm like going to go crazy, and I'm going to say, okay, int sum is equal to, I don't know, argv1 plus argv2. This is not going to work, okay, because I'm trying to add up some strings. It's going to be madhouse. Okay, so if I compile it again, it's going to say, okay, well, this is kind of invalid because you're trying to add up two strings, okay, and that's not going to work for us. So there is something that you can do where you can actually make sure that you can convert things to integers from the line, and then you can actually do maths with it. So if we do that, I think it's in this one. Yes. Okay, I've got it doubling the odd numbers, but let's not do that yet. Let's just do something simple. Okay, so I've got this main. I know that I'm taking things off the command line because I've got my int argc char star argv. Okay, fantastic. So I'm going to be doing something magic here. Now you will note that over here I have my normal standard library, input output, but then I have this library over here, this standard library. So I've included this standard library to have access to a very special function. Okay, and that function is a to I, and this is the function that converts to an integer. Okay, so it'll convert that string to an integer. Okay, so this is why I've got this standard lib.h. So standard library, I'll include a little comment here so that you don't forget, included to have that function. Okay, great. So if I'm going to be adding some things, okay, the first thing I want to do, let's say I'm going to run my program. So let's say it's going to be whatever program, and I want to add those two numbers up, okay? The 3 and the 5, I want to add them together. That means that I want to have how many arguments in my program in total for it to be actually able to do anything. What do you guys reckon? If I want to run a program and I want to add up these two numbers, what is the minimum number of arguments I need to input into the function, into 3? Yeah, perfect. So if I have anything less than 3, it's not going to work for us. So I can error check for that. I can actually check that argc is greater than 3. Otherwise, I'm not going to, there's not enough parameters to actually work anything with. So otherwise, I can printf. So if it's, you know what, I'm going to turn that around and make that an error message. So if it is less than 3, that means there are not enough arguments to add up. Okay, and that's it. And then I'm going to return out of here. Okay, now always, always, always seen me write return 0. What do you think this return 1 means? Yeah, it's something went wrong. That's it. You're just saying something went wrong. I'm exiting out of here, and the program exited with an error. It didn't exit. Nothing ran successfully. So someone just in the chat asked to explain simply what argc and argv is. So to take in command line argument, I hope I'm explaining it simply. Let me know if I'm not. But argc is what counts up, and then Bella's doing it as well. So argc counts up how many things you put in on the command line. So for example, here I've put in 1, 2, 3, 4, 5 things into the command line. And argv is the array of strings. So it stores what I've actually put on the command line when I run my program. And CLA is just the name of the program. When I compile it, I gave it the name CLA. Okay, great. So now we've checked that there is enough arguments for us to proceed. And now we want to add up the two things, okay? So let's add up the two things, or we'll add up every single thing on the command line. So as long as there's two things to add up, we'll keep going. Maybe it's 6, 7, and we'll just loop through and add it all together. So let's do a loop. And I is going to be going until I is less than argc, because that's the number of arguments. And then I'm going to do I++. Okay. So before I go on, I've got int I is equal to 0 because I'm on autopilot. But if we remember, the first argument at index 0 is the name of the program. So I'm not going to be adding the name of the program to anything. So where should I be starting my count? So in this case, my argv 0, if I use that one above, that's going to be program. Then my argv at index 1 is going to be 3. My argv at index 2 is going to be 5. My argv at index 3 is going to be 6. And my argv at index 4 is going to be 7. So where should I be starting over here? Should I be starting at 0? And that means I'll be starting at this very first argument. Should I be adding it up? I can see a few people have commented, nope, we'll start at the first one, because the first one is the actual input into the program and not just the name of the program. Okay, so if I've started at 1, I just want to add things up now. I don't actually have anything to add. I'm just going to do a variable that I can use to add things. I'm going to start it at 0, so I've just done a variable that I can use for my addition. So what I'm going to do here is I'm going to say sum is equal to sum plus, and then and then I'm going to use this a to I function, and I'm going to give it an argument. So at index I. So what that will do is it will say sum is equal to sum, and then sum, whatever it was before. A to I will be the function located inside standard library, and this is the function that will convert my string to an integer. Okay, and then I'm giving it what I wanted to convert, the string. So whatever is sitting at argv I want it to become an integer. Yeah. Okay, and then let's just make sure that it's all working. So I'm going to print out the sum is, we're all cooked, that's the sum, and sum. Okay, so let's clear this out so you can see exactly what happens. So a to I is the function that converts from a string to an integer. So over here, this function, a to I, in standard library.h above, so which we've included here, converts from a string to an integer. So you saw before I couldn't add them up because these were strings and it wasn't going to work. Whereas a to I will make 3 an integer 3, and then it will make 5 an integer 5. So it will allow me to actually add them up. So if I compile it now, so I'm doing it the normal way. So DCC, oh, I actually had A2I. Okay, doesn't matter. Okay, CLA demo dot, no, num.c. Let's call it something else just so that you can see what's going on. Let's just call it demo to make it. Okay, so we're compiling it. It's compiled. I'm going to run it with the name that I've given it. Okay, and now I'm going to give it some arguments. I'm going to give it 3, 5, 6, 7, and this is going to test your mathematical ability. We're now doing 3 plus 5 plus 6 plus 7, which is 21. So amazing. So amazing, okay? And we can even, if you want to see how it's working, okay, we can do printf argv. So I'll start like this, just so that you can see what's going on. And this is going to be I and argv at index I. Okay, so if we run this again, and I'll run it again, it's going to give you all of these, right? And then it's going to give you the sum. And the sum is only possible because I've used this A2I function, which converted it to integers, so I can actually do it up. Okay, let's see what happens when there's not enough. So if I just run the program with nothing there, it'll say there are not enough arguments to add up. If I run it with one thing, it will still say that. And then if I run it with two things, it will not say that, because now I've got 3 arguments here. There is 1, there is 2, and there's 3. So now I can actually go ahead. I will not go into this if statement, and I'm just going to actually do the business of what I want to be doing. Okay, how is that feeling? What's the point of return 1? Okay, this is a very good question. So out in the real world, not here, okay, you often tracking when a program exits with an error code. Sometimes you will give different error codes as well. So sometimes this return will help me debug as well. Like I will know what I exited with. Let's say I exited with 430. Then I know that a particular error has occurred or a particular statement has been accessed, and that's where the error has started. So it allows us to see when something has gone wrong and why something has gone wrong, basically. Okay, can we please do a little poll of how it's all working? I don't know if Sophie or Bella have heard me, but I hope so. What's the name of the thing? We just learned command line arguments. For the person that doesn't have a main, you should still have an int main. It's just that in brackets instead of void, you have something else in brackets here, but you should still have an int main. How bizarre. Error, your program does not contain a main function. What are the real world applications? You often have to give a program something to run with straight away, as opposed to inputting it just from the user. So it's going to, you would use it. You don't use it as much, like we don't make you use it as much in 1511 as we used to, but there are real world uses for it, Lots of things use command line arguments. So lots of things will take something and then run with it. What would happen if you had more than 3 arguments? Nothing. It would just keep adding them up, right? It'll keep going. So I can have, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, you know, go to town. It'll just keep adding them up. Yeah. And DCC, you give arguments to DCC when you compile it. I wish, Science Moth, whoever you are, I wish I could walk up to your computer and see what's going on. Sometimes close it, open it again. Okay, do you want to do one more? One more? Yeah, okay, let's do one more. Should we do one more with numbers or with strings? What do you want to practice more, ints or strings? Strings. Okay, let's do a quick string programs. String, blah. That was verbal diarrhea. Do one with 6, 7. Ah, I could do this one with 6, 7 and then just call it a day. 6, 7, 6, 7, 6, 7, 6, 7, 6, 7, 6, 7. Ah, amazing. Okay, let's do, don't leave. No, stay. We're going to do strings now. Okay, I'm going to do this one. I'm going to do most common command line argument. You were the person that left the lecture hall. No. Okay, so what we're going to do is taking some command line arguments, then print out the most common command line argument and how many times it has occurred. So we need to find the most frequently occurring command line argument. We need to count how many times each argument appears, and we need to track which argument has the highest count. Okay, so what that means is, one, I'm going to, first of all, because I'm going to be comparing some strings, I'm going to include string.h. So I'm going to use string compare function, which means I need the string library. Yippee! Amazing. And then I'm going to need some command line arguments because I'm working with command line things. So I'm going to do int argc char star argv. Amazing. So this allows me to take in command line arguments. Then I'm going to check that there are enough arguments. So first argument is the program name. So we need to have at least one more argument to find a most common term. Yeah? Does that feel okay? Okay, so we need to have at least one. So that means I want my argc to be two or more, right? So sorry, one or more arguments. So if it's less than 2, then I'm going to print out not enough arguments. I'm going to return 1 to signal that something is wrong, which is just like a standard thing that we do. Return 0, standard, means return success, that everything went well, the program has run its course. Return 1 means that it exited maybe before, before it finished running and everything was not okay. And there are other error codes that you can return as well, which can help to indicate perhaps what has gone wrong as well. Okay, great. So now what steps would we need to do to solve this problem? What do we think? What do we reckon? So the goal is to take command line. So let's say I'm going to run it like this. Dog, 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 cat. And it should return to me the dog is the most frequently, so it will return most common term is dog, which occurs 3 times. Yep. Okay, so we will need a counter. I agree. So first steps we need to do is we need to initialize and declare. So we'll need to declare and initialize some variables to track the most frequent argument. Track highest frequency as well. I agree. And then we need to think, what are we going to do for each argument? Okay, so for each argument, yeah, so we're going to condition, is it dog or cat, but it could be something else as well. Okay. Yeah, so lots of good ideas. Can I suggest, I'm going to suggest one. So for each argument, and where should we start counting the arguments? Is it at index 0? One. Excellent, because index 0 is going to be the name of the program. So we're going to start counting at argv1. Okay, so we want to go through the array of strings, so our argv array, and we want to count how many times it appears, the first one. And then if the current that we're counting appears less than the next one, we want our most frequent to be the next one. Something like that. Yeah? Okay, so let's try it out. Let's see what we can do here. Okay, so I want to track two things. I'm going to track that maximum frequency. I'm going to start it at 0. And I'm going to also track the index of the most common thing. So track which argument has the highest count. We need to count how many times. Okay, so I'm going to also keep track of the most common index. And I'm going to start from 1, okay? And then I'm going to change the index of the word anytime that it is less or more or whatever else. Okay, so great. Now, let's do it. Okay, first loop. I'm going to start with I is equal to 1. I is going to go until argc because that's the number of arguments that we have. And we're going to do I++ to move along. And then I'm going to do some other things. Okay, so what am I going to do next? So let's say I've got, this is where it's handy to draw it up. So let's see, look at this. Got some amazing thing going on today. Okay, so if I have I've run this program. And I've got dog, dog, cat. So let's say I start counting over here. Yep. I'll start counting at argv1. And argv1 is equal to dog. I want to then compare it to the next one. And if it is the same, I want a counter to increase to count it. Yeah, so I'm going to increase the count if it's the same. Then I want to compare it to the next one after that. And if it's not the same, then I don't do anything. And if it is the same, then I increase the counter again. Oh, can you see? No, it's completely cut off. Here we are. There we go. Okay, So my argv1, I start counting at that. I have the fact that it's a dog, then I increase the counter when I compare it to the next one. So what I'm doing to start with is I want to be comparing it, so I want this loop to go through and compare it to all the different elements. So let's try and do that. So let's have a counter to keep track of the current count, which I will increase if it's exactly the same thing. Okay, and then what I'm going to do is I'm going to compare them, yeah? So if, let's use this string compare function. So if string compare argv at I, and how do I now keep track of the next one? How do I, can you see the problem that I've run into? strcmp is a function in string.h library that compares two strings and lets you know if they're the same or not. Okay, I'm going to do it. Can I suggest? I'm going to do it, and in the interest of time, I'm going to do it in a way that's going to have two loops. I'm going to have an outer loop, and this outer loop is going to pick the word to count, okay? So that's going to pick my argv1 or argv2 or argv3 or argv4, blah, 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 blah. It's going to pick the word that we're going to count. And then I'm going to have an inner loop, and that inner loop is going to keep track of what's going off the next word after that and the one after that as well. Okay, because I'm counting up the words and I want to count every instance that the word occurs, I'm going to count the very first instance of it, which is why I start J at 1 as well. Okay, so now I'm going to compare the strings. So let me do that. So I'm going to compare argvi and I'm going to compare argvj. Presumably the first time this runs, it's going to be the same. Yeah? So the first time it runs, the two words will be the same. So if they're the same, string compare gives me 0. So I'm going to say if it's equal to 0, that's string comparing function. This function is inside string.h. Then I'm going to increase my counter. So this counter is going to go up, and that means that that word has occurred however many times. Okay, great. So I've run this. I am now I want to see, I've compared one word across all of them. So now I want to see if it is the maximum frequency or set it to be the maximum frequency, right? So now what I want to do is I want to update if this word is more frequent than any other that has already been counted. Okay. So we'll see what happens. We'll try it out. Okay, so if my current count, which is the count that I'm counting it in here, is greater than the maximum frequency, which is set to 0 to start with. So the very first time it's going to be set to 0. So if that current count is more than that, what I'm going to do is I'm going to set my maximum frequency. I'm going to set it to the current count. And now to keep track of the word, I have my most common index, which is set to the first word. But if something has occurred more, then I'm going to remove my most, and I'm going to reset my most common index to whatever that word is, which is in the outer loop where I've picked the word. And then the inner loop here is picking up all the other words to compare against. Okay, and then I guess it prints the result, and the result will be here. The result will be argv at index most common index, because I've kept track of which one that is, and then the maximum frequency. Okay, it will compare the first word of the same words, okay? You'll see what I will run through it in a second. Okay, here we go. So if we were to compile it, and then let's run it. Let's do dog, dog, cat, or even a car. Okay, most common term is dog, which occurs 2 times. Okay, so this is the way it's working. Okay, let's quickly have a look. It's not the most efficient way to do it. In my head, it was the easier way to do it. Perhaps not. Okay, so you can remove this nesting as well, and you can try it in different ways, okay? So basically what we're doing is this, okay? You've got, I'll start from here. So we've got 2 variables here. So the first variable is max frequency, and it's the one that counts up how often something, like the maximum time that something has occurred. And then I have one that I keep the index with, so that I know which word has occurred the most, okay? So I'm going to set that to 1. That's set to 1. So I go into the first loop, and in the first loop, I've got an I is equal to 1 to start with. I check that I is less than argc over here. So it's less than, and I've got, in this case, I've got 1, 2, 3, 4. So I've got 4 arguments. So it's going to check that I is less than 4. It is. And that means I'm going to go in here, and inside that function, I'm going to have one more thing, which is current count. And that current count is going to be equal to 0. Okay, great. It's equal to 0. What do I have next? Next, I'm going to have another loop. And in this case, I'm going to have my j is equal to 0. So I've set my j is equal to 0 now. J is less than argc. It's less than 4. Yes, it is. So I'm going to go in here, and I'm going to compare. So argv, j was not set to 0. J is set to 1. I'm sorry. I can't believe someone let me say that. So I'm going to check. This one is index 1. This one is index 2. This is index 3. Okay, so what I'm trying to do is I've picked my first word in the first loop. So on the outside loop, I've picked my first word that I'm going to compare against each of the other ones, okay? So in my first word, I've picked it, that's in the outer loop. In the inner loop, that's where I pick up every other word. So I now compare argvi and argvj, which are both at 1. So I'm going to compare dog to dog. And they are obviously going to be the same, which means I'm now going to increase the current count to 1, which is fine. I want for that to happen because what that means is I've actually counted the first occurrence of the word. Okay, excellent. So the next thing I'm going to do is I'm going to go out of this if statement. I'm going to increase j by 1. So j is going to go to 2. And I'm going to compare, okay, is 2 less than 4? Yes, it is. I'm going to go back in here and I'm going to compare again. So this time I'm comparing j at index 2. So I'm comparing dog and dog, okay? They still give me 0. It's still the same, which means I increase my current count and I increase it to 2 now. Okay, great. So now that's 2. I exit out and it becomes 3. J now becomes 3, okay? When it becomes 3, I compare again. Is 3 yes less than argc? Yes, it is. So I compare again. This time I'm comparing this first dog with cat. Now, those are not equal, so I don't increase the count, but I do increase the j by 1. So I've increased it by 1. It's now 4. So I break out of this because 4 is not less than 4. So I break out of this for loop and I go back to my initial loop and my I increases by 1. So I now becomes 2. Which means that I've now moved myself to the next word. So I've now moved myself to this word. So now I'm standing at the second word over here. And what I'm going to go back and I'm going to compare again. So current count back down to 0. Okay, so my current count is now back down to 0. And I start this again. My j goes back to 1. And I compare again. So I am counting them again, but it's not going to happen more times than the first time it counted, if that makes sense. So then I'll compare it to j is equal to 1, this one and this one. They will be equal, which means my I actually forgot to do all of this. I didn't break out of. When you break out before the I happens, I compare this. So current count has to be less than max frequency, which it was, which means that max frequency became the current count, which at the last was 2. So this should have become 2. And then most common index is I, which was 1. So most common index stayed as 1 after the last thing. And then I increased my I, and then I started going again, and then I started comparing again. Okay, how are we feeling? Just cooked? Absolutely, absolutely cooked, I'm sure. For string compare on line 41, oh, someone's answered it, sorry. Bella's answered it. Okay. All right. Do you want me to keep running through it, or are you happy for me to stop? All right, go on then. Give me something. What's line 48 to line 50 about? This part here. Okay, this part is the part that actually helps us to set the most frequently occurring thing. Okay, so basically what it's doing is once I have a current count, I know how many times that word has matched, and I'm going to set it to the max frequency if it's more than other. And I'll also keep an index of the word that it has happened to. No, next week is flex week, and then the week after you're going to have pointers. So I am going to move on from this, and we are going to do pointers. And there will be like small exercises or maybe some debug exercises that will be to do with your command line arguments. In the exam, we might use it to take in some command lines, but the logic stays the same. It's just that you're taking things from the command line as opposed to with fgets or with a user, right? So the logic of how you play around with strings does stay the same. That melting emoji now. Okay. Okay, let's move on. Let's go to pointers. We can always come back to this. There's going to be at the end, I've got like 2 lectures worth where you can tell me what you want to revise towards the end to prepare for the exam, and I'll give you questions that are kind of like the exam. We're going to work through them in the lectures and so on and so forth, okay? Okay. No, you learned string compare last week. Amazing. Okay, let's do it. Let's move on. Do we want a 5-minute break, or how cooked are we? Break time? Let's have a 5-minute break. It's good time actually. 2:55. So when it gets to 2:55, 3 o'clock, then we will come back. 3 o'clock, we will come back, and then we will do pointers, which is also a bit of like an outdoor cook fest, a barbecue. So you'll enjoy that. Okay, you want to do a Kahoot? We can do a quick Kahoot as well, just to break the, to get a bit of, I don't know, just a bit of zen going again. All right, break time. even the Kahoot is cooked. It doesn't want to play music for us. All right, 3 o'clock. I'm gonna keep some serious time today. We're gonna go strong. All right, ready, team? 3 o'clock. I'll give you 1 minute. Whoever wants to participate in the Kahoot, we're gonna just punch it up. Lock in. Oh, sad. Not that many people want to do the Kahoot. Oh, it's back. Look at that. Coinciding with more people. See, the Kahoot was also not going well. All right, let's do it. Ready. Let's see how many mistakes I made this time. Amazing, your rows and columns. Who's on top? The knowing cheetah. Amazing. Amazing. 4 by 5, 20. Knowing cheetah still on top of the podium. Let's see where the indexing throws you. Going on here? Remember 0, 1, 2. So 0, 1 and 2 because 0, 1, 2. So 6. Okay. Onwards. Knowing cheetah still on top. Can anyone throw them off? Rows first. Yeah. Very good. 1, 2, 3, 4, 5, 6. So there's 6 things in there for the string length, yeah? It doesn't, string length, strlen does not count the null terminator. It does, yes, counts the space. Knowing cheetah. Okay, still going. Halfway through and they're still there. Just thought I'd really throw you with this one. Little string literal here. How big would it make this array? It is legal, and there's going to be one space in there for the null terminator. Amazon Kingfisher, woohoo! Well, you should know this one after we just did that. Let's see who remembers something from 5 minutes ago. Ah, 12 people do not remember from 5 minutes ago, but 72 do. Yay! Oh, Amazon Kingfisher still holding the lead. Very good. Ish. So 0, 1, 2. Yeah. Amazon Kingfisher still on top. It's dog. It's always dog. I'm trying to prove a point. It is always dog. Now I'm really messing with you. Now I'm really messing with you. Okay. 0, 1, 2. 0, 1, 2, 3. It's gonna return a D. Yeah, things are messed up. Strings are so messy. Lots of arrays. Remember, a string is just an array of characters. Okay, Miraculous Camel is now on top. Okay, I've given more time for this one because obviously it's long. Be careful. That's very, very good. Okay, just note here that the sum was adding I, so on the diagonal. Yeah? So 1, 5, 9. Okay, Amazon Kingfisher is back there. Last question. What is printed? Messing with you again. Be careful. Last few seconds. Here we go. Here we go. I've messed with you. I swapped the rows and the columns. Array JI. The rows and columns were swapped. All right, let's see who's on the podium. We have at number 3 the Knowing Cheetah. Number 2 is the Amazon Kingfisher. Oh, who's come first? Oh, Miraculous Camel. Just really came from the back. Unbelievable. Just took it out at the last minute for the win. Amazing. Well done, well done. Okay, the fun is over. Now the fun is finished, and now we do pointers. I'm sure everyone is super excited about this. And even if you're not, you're about to be. Yay! Okay. So, what is a pointer? Everyone makes it out to be that pointers are so scary. And you know what? They can be. Only because you have the ultimate power. You're now dealing with memory and you're dealing with elements of memory. But all you have to consider is that a pointer is just really another variable type. Okay? So all it means, like an int, like a double, like a char, like an array, a pointer is just another variable, but what a pointer stores is a memory address. So it doesn't store a character or a number, it stores the address of where that something might be, right? So it stores a memory address of a variable. That means that you can modify things directly at the source, okay? And that is, that has some security issues, but also it's very powerful because it allows you to do lots and lots of things, and it allows you to use functions more effectively. It allows you to return things more effectively. So it gives you a lot of power and a lot of flexibility in how you go about things. So now you've seen it a few times now, but to declare a pointer, you need to specify what type that pointer is pointing to, okay? So you start with type that it's pointing to, then you do that little star, the asterisk, and then the name of the variable, just like you would normally, right? So for example, if my pointer is pointing to the memory address of an int, then it's going to be an int star, okay, pointer. It's cut off. Oh, yes, it is. Okay, sorry. My OBS is not being very kind. How is that? And I will also move myself to the other side. Is that better? I have. I saw that my head was blocking everything. Yeah, the left doesn't really matter. I can fix it, but then it makes the font smaller. Here you go. Now you can see everything. No. Okay, great. So you declare what it's pointing to. If it's pointing to an address of an int, then it's an int star pointer, okay? So that's the name of the pointer, called pointer, to make it not confusing, and then int star. Okay, great. So what does that mean? Okay, so let's say I've got a variable, okay, and that variable is of type int, it's called number, and I will assign the value 2 to it, okay? So in memory, and these are made up memory addresses because they are not how that works, okay? So made up memory addresses. So in memory, what it looks like is now I have a piece of memory at compile time allocated to this variable int. I know exactly how much memory to give it because I've said what type it is. So I know how much memory an integer needs, and I've stored the value of it in here. Now, if I want a pointer to this variable, okay, then I will declare a pointer. It's pointing to an int, so it'll be an int star. Now, I used to work at a place where you would always name pointers with a underscore and then PTR. It's very old school, but I still do it often. Helps me to read my code and understand what's going on afterwards. But I'm now pointing to the number, and what I'm doing is I'm giving it the address of that variable. So you remember that the ampersand is what we use to indicate address of. You've used it in scanf before, so now you're using it to actually assign the address of. So what that means, if I have this variable and it's a pointer variable, its name is number pointer, and I give it the address of number, what happens is inside this variable, I now store this bit here. So I store the address. So number is equal to, not 13, I don't know where I got that from. Number is equal to 2, and then the number pointer is equal to this address 0xFF40. Okay, so there are 3 things you need to remember with pointers, and we're going to play around with them in a second, okay? So don't worry, we will play around with it. Okay, you declare a pointer with a star, so the type that you're pointing to. If it was a character, it would be char star. If it was a double, it would be a double star. Okay, so depending what that variable is storing the memory address of, that's how you're declaring it. So int star, and then I give it a name. So the star is declaring a pointer. So I declare with a star. I initialize a pointer by using the ampersand symbol because that says the address of. So I initialize it with this ampersand. And finally, there is something called dereferencing a pointer. And what that means is that I want to know what is actually at the address that the pointer is pointing to. Okay, so kind of like this. So let me draw it for you because it's really a bit of a mess without a drawing. So it kind of looks like this. So if I just gonna move this along, and we'll have the board. So let's say okay, so let's say I have my int, and I'm going to call it number, and that number is equal to 67. Okay, so amazing. Okay, now in memory, let's pretend that this is a piece of memory. I've got a whole bunch of bits of memory floating about, blah, 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 memory. Let's say these are the addresses of my memory. I'm just going to hold them like this. And it's cut off. Great. Okay, how's that? Everyone can see that. Okay. So I've got some memory addresses. So my number, it allocated, let's say over here. So I've got this number and it's equal to 67. Great. 67. Fantastic. So now I want a pointer. I know that I'm storing an int here. So my pointer is going to be to an int. Then I'm going to have a star to say that it's a pointer. And I'm going to call it whatever I want. It's just a variable name, same as any other variable. I'm going to use the ampersand to say, can you store the address of number in there? Which means that my number is now equal to 67. Then my number pointer, so is going to be equal to the address of number, which is B. So it's equal to that address. Yeah. Okay, great. So there is a way to print out the address. It's coming, don't worry. And now I want to know what is sitting inside that address. So if I'm dereferencing a pointer, I will ask for the dereference, this symbol here, the star. And if I print out, okay, can you tell me what is sitting? %d printf. If I do like a %d printf, because I know that there is an int in here, and I use this star, what it means, go to the address stored in here. So I'll go to this variable, I'll see the address that's in there, I'll go to that address, I'll take what's sitting at that address, and then I will output it here, okay? So that star is going to be dereferencing that pointer. So it's saying go to the address of and tell me what is sitting in there, okay? And find out what is at that address. So 3 parts to a pointer. You declare it with a star, you initialize it with the ampersand, and then you dereference it again with the star, okay? And we'll see it in action right now. Shall we see it in action? A simple pointer, just so that you can see what's going on. How does that sound? What's happening with the chat? My goodness, lots of deletions. Is everyone okay? Is everyone feeling okay? Why are we spiraling? Are we spiraling? What's happening? Talk to me. Okay, hi pointers. So nice to have you included as part of this course. Okay, let's do it. Include stdia.h and int main, void, oh my goodness, great. I'm having a complete meltdown and it's 3:20, amazing. Okay, great, so we've got our little pointer, things are going well. Well, we don't have a pointer yet, we have nothing. So we've got our int main void. Let's do that simple demonstration and then I'll print it out. Okay, I'm going to call it my variable, okay? And I'm going to make it equal to, what should we make it equal to? Anyone give me a number? Throw me a number, any number. Fine, it's 42. It's the meaning of life. It just had to be. Okay, great. So this is just a normal int variable, okay? So now I've declared it, I've assigned a value to it. Now I want a pointer to store the address of the variable above, okay? So I'm going to have, since the variable above is an int, it's going to be an int star, and then I'm going to call it, this is just the name of the pointer, okay? It can be anything you want, okay? It can be called my pointer. It doesn't matter, right? It's just a name, okay? And that's going to be equal to, because I'm assigning a value to this, and I've told it that it is in fact a pointer, I can't do this, right? That doesn't actually assign, they're not equal to each other, okay? They are not balanced because one, when you say this means that I expect an address. I don't expect an integer. So to get the address, I use the ampersand symbol and I type the name of the variable that I want the address of. So now this variable here stores the address of this one. Keep in mind that this variable, when it's created, it has its own memory address, right? Okay, so it's not like it doesn't have it. So now this variable has been declared and it's been initialized, okay? So now let's do some printf statements just to see what's going on. So let's do the first one. So the pointer, my variable pointer has value, and now this is a new percent. Percent %p is the one that prints out a memory address. You don't have to know it, right? It's just to show you what's going on, okay? And so I want to show you that this pointer has its own address that's not the same as what's stored in it. So the pointer, my variable pointer, has value p. So now that's got the same, so that's whatever is stored in here. So I want to know what is stored inside that variable. Then the next thing I'm going to print out is I'm going to show you that the pointer has its own address, and its own address is also p something, but its address is going to be at the address of that pointer, right? So my variable pointer. And then finally, it's pointing to the variable, my variable, and that has the value %d. And so to dereference the pointer, so right now the address is inside here, so I'm going to dereference this pointer. So I'm going to make it go to the address stored in there, and then it's going to take the value that is stored in there. So I'm going to start and then it's going to go to that and point it out. Okay, so should we try it out? Let's see what it gives us, and then we can talk about it some more. Okay, let's do clear this, and let's do DCC high pointers. Okay, good chat. Nailed it. Semicolon. An anticlimactic presentation. Okay. Here we go. And let's run it. Okay. So the pointer, my variable pointer, has value blah, so that's the value of that variable. The pointer has its own address, which as you note is different to the address that's here, and it is pointing to the variable my variable. Now, what do you reckon? If I rerun this program right now, will it give me the same outputs over here? What do you think? Yes or no? Will it give me the same outputs? No, it shall not. I mean, it might, but the odds are very low of that happening. So if I run it again, it's going to give me something different. If I run it again, it's going to give me something different again, because on every run of the program, it assigns memory to it. And then when we exit out of the program, that memory is released again, right? Okay, how does this feel so far for pointers? So think, this is often an analogy used for pointers, and sometimes I don't like it, sometimes I like it. There are some gaps in it. But okay, I live at a certain address, okay? And so the value of my house is going to tell you where to go. So that's like the address. Now, if you want something from my house, you have to go to that address and get that something, and that's the value of it. So a pointer stores the address of my house, and when I dereference the pointer, what I'm saying is go to that address, get that something, and bring that out to me. The need for pointers is great. It allows us to change things right in memory without, doing anything else. You have in fact already been using this, and you've already been doing it without realizing it, right? Because an array is not the same as a pointer, but when it's passed around functions, it's passed like a pointer, okay? So what it allows us to do is it allows us to, when we have functions, it allows us to, because we can only return one thing from a function, right? Whereas having pointers allows us to have more flexibility in how we write and do things, because we can modify multiple things in one function potentially. Yeah. And think about scanf, right? So when you have scanf, you've been using that ampersand, because what you're taking something and you're putting it at the address of, right? Because you've declared a variable, and then you need its address to be able to know where it is you want to store something into. Okay, let's do, I wanted to quickly go through, that was a very simple pointers. I'm going to do one more pointers example, okay? And I'm going to use the swapping numbers around. Maybe I'll do that first. Yeah, I'll do a swapping function, which is like one of the most common ways that people love to show why we need pointers. Okay, so let's do a swapsies. Okay. Okay, so let's say that I want to swap two numbers in a function. Okay, so I want to swap two numbers in a function. How can I do this if I want to do that? If I have, let's do a hash include Okay, we've got, and then I'm going to have some sort of function that swaps the two numbers around. So let's say I'm going to send it number 1 and number 2. Yeah? Let's see if it works without using. And then we'll have after the swap. Okay, great. So I've got this function that I want to write. Now, what's the function going to return to us? I'm swapping two numbers around. What do you reckon if I were to make this function here now? What could be the output of that function? So input, I've given it the 2 ints to swap. But can I return the 2 new numbers? Can I give back 2 numbers? Yeah, so a few people saying void. I mean, I could hypothetically return 2 numbers with a struct, but that is, I like the way that's thinking. So this is why I want to use some pointers, right? I can only return one thing. So I'm going to return nothing from this function. I'm going to change things at the source, right? Which means this function is going to be void. It's going to be called swap. But I'm not giving the function 2 numbers, right? What I need to give it is 2 addresses, because I'm going to make the modification directly at the address. So I'm going to swap exactly what is sitting in memory, and that means I don't have to return anything to it. Now, what that means is I have to send 2 addresses to this function, okay? And what that means is that I'm sending it 2 pointers. So I'm sending it 1 pointer to an int, okay? So that's going to be 1 pointer, and I'm sending it a second pointer. What happened to my opening bracket? Disappeared. Okay, great. So now, how do we swap things? Let's say I've got a glass of milk and I've got a glass of orange juice, and I want to swap one into the other. How can I do it with 2 glasses, or do I need something else? Your assignment 1 does not need to use pointers, okay? You don't need, this is for your next assignment. Don't worry about it for this. Assignment 1 should be done without pointers. Just pour the milk on the floor. I agree, I hate milk. I don't hate milk, but you know, I don't feel anything for it. I'd rather have the juice. Okay. Yeah, I'd just have a temp variable. I'd have a 3rd glass that I would have to pour something into. So I'm going to have a temp, and what I'm going to do in that temp, so remember that what I have is a pointer to an address of. So my temp is an int, which means that my temp is an integer. So I can't do number 1 pointer here, and the reason I can't do that is because that holds a memory address, okay? So what I need to do is not assign it a memory address, but what I need to assign it is what that memory address is pointing to. So I will dereference that pointer, which will allow me to see what it is pointing to. Okay? Then I will take that glass that I've just poured out, and I will dereference it again, okay? And I'm going to dereference a second point and pour the second glass into it. Yeah? So now they're equivalent. And now what I will do is I will take the second glass and again dereference it, and I'm going to pour into it whatever was sitting inside that 3rd glass. Dereference means go to the address and grab whatever's sitting at that address and then put it into that variable. Okay? So this is going to swap the 2 numbers around. We're going to run it, and then I'm going to draw it up so you can see exactly what it's doing, so that you're not lost in all the stars, okay? So let's run it first. Let's DCC swapsies. Good chat. Okay, let's try this again. This time with more success. Okay, and before swap, the numbers were 10 and 20, and then after the swap, they're 20 and 10, right? And that's, I haven't returned anything, I've used a function, so I've used pointers to allow me to do that. So now let's see how that works if we were to draw it up, okay? Let's see how that works, okay? And then we will go on to the next thing. Okay, where's this whiteboard? Whiteboard is here. Let's move this along. And let's move this along. And I'm going to swap colors to okay, so let's do it. So I'm just going to move this. Just tell me if you can't see something. And then please let me know in the chat if it all makes sense. Okay, great. So the first thing I'm going to do is I'm going to go into the main. Yay, we're in main. And we've got a variable called number1. Okay, so the number1 has been declared and the number 10 has been assigned to it. Then I move to line 10 and there is another variable and that variable is number2 and we've assigned the number 20 to it. So I'm now on line 10. I go to line 12, I print out before swap. I go to line 13 and I print out the two numbers. Okay, so the numbers are number 1 and number 2. Okay, fantastic. Now I'm going to call the function swap, and what I'm going to do is I'm going to give it some addresses. So instead of doing it the way I normally do it, what I'm going to do is I'm going to pretend I have some memory here. And some memory, some memory, some memory, some memory, and this is address A, this is address B, this is address C, this is address D. So let's say number 1 is assigned this bit of memory. And let's say number 2 is assigned this bit of memory here. Okay, so this is my int and it's 10. This is my int and it's 20 sitting in memory. So when I call the function swap, when swap is called, what I'm giving it is I'm giving it the address of number 1. So I'm giving it the address, which is A, and the address of number 2, which is C. So I've given it two addresses to call the function with. I will move down to the function and I will now undertake this function. So the first line in this function is I've got another variable. This variable is of int and it's temp. And what I'm going to do is I'm going to assign whatever is sitting at this thing here. So remember, when we call this function with these two addresses, these addresses are copied into here. So what that means is that my number 1 pointer has inside it address A, which is the first thing I called, and number 2 pointer variable has the address C in it, which is the second argument that I gave it. So when I call this, I've got this variable temp and I go to this side and this side says, okay, could you please dereference this pointer? So inside my number 1 pointer is the address A, and the fact that there is a star here says, go to this address A and pull out what is in it. So I'm going to go to A, I'm going to check what's in A. In A is number 10, and I'm going to assign it to 10. Then I'm going to move down to line 27, and line 27 tells me, can you now dereference number 2 pointer? So number 2 pointer stores the address C. So if I dereference it, what it means is I go to the address at C and see what's sitting there, and there's number 20 in it. So that's going to be equal to 20, and assign it to a number 1 pointer, dereference number 1 pointer. So take the number 1 pointer, which is address A, and go to that address, and then assign the number 20 to it. So now this is going to have the number 20 in it because I've dereferenced this number 1 pointer and I've assigned it whatever was sitting in here dereferenced. Now the next line, I'm going to take temp, so whatever is sitting here, this 10, and I'm going to assign it to the dereference number 2 pointer. So number 2 pointer is still the address C. To dereference it means go to this address, C, and then chuck the 10 in there. So now this is going to be 10 instead. And then I'm going to return to the place where I got called from, and I'm going to print out, that should say after the swap, and then it's going to print out the two numbers. Where number 1 in memory is now 20, because I changed it in memory, and number 2 is now 10. How does that feel? So B and D were just to show you that there is more memory floating about. They don't actually come in, right? Ah, yes, I can move my face to the middle. My face is really in the way today. Do you want me to switch it off, full stop? Okay. So let me look through the question. What is the point of the and in calling? Okay. So the point of the ands is that these are pointers, right? So what I'm doing, a pointer is storing, okay, so a pointer is a variable that stores an address, okay? So I have to send it the address of something for it to be a pointer. So what I'm doing is I'm giving it the address of number 1. So I'm giving it the address of wherever this variable is stored at, which is the first pointer. And I'm giving it the address of whatever this is stored at, which is the second pointer. Yeah? So I'm sending addresses into the function because that's what a pointer is, an address. Does this feel a little bit better? Can we do another poll? This poll is now old. Can we do another poll to say whether that feels better or not about pointers, seeing it in that function? So when I go to print out the swap numbers, I'm just using this, right? I'm using the variable names to show you that the swapping happened at the memory addresses somewhere else, and yet the variable changed in my main function. We would rather you not use pointers in your first assignment and do it without. Yeah, so it is working. Like number 1 and number 2, I've changed. So I'm just using the normal variables in my main, even though my change happened elsewhere. How does pointer number 1 know it matched the number 1? Because when I did the swap, this bit here, I've sent it the address of the first variable. So I've sent it the address of this, which means that this thing here then has the address of this first variable when I've used it. So in temp is not an address because that would be a mismatch. And that's why I've dereferenced it, okay? So this thing here without the star, that's holding an address, okay? It's holding an address. When I've added the star to it, it's gone to the address that it's holding and pulled out the int that it's holding and assigned it to temp. So both sides have to match. It can't just be one side is a pointer, one side is an int. How does that feel? No, you can have, if you've used pointers, use pointers, that's okay. But just don't feel the need to use pointers in your assignment 1. How are we feeling? Okay. I know that a few of you are still saying it's not quite clicking yet, and that's okay, right? It would be actually insane if you were like, oh my gosh, we've done it for 20 minutes, makes perfect sense, moving on, I am now an absolute master at the pointer, and at every other thing that we've learned today, of which there were many, right? That's not how life works. It will take time, and we will keep repeating it, and you'll have a tutorial, and then we will keep using pointers as well, okay? So line 27, again, when you made, it's pulled from these two things here, right? From the two arguments that you gave this function. So I sent it with number 1 and number 2, the addresses off, and that's what got copied into these two variables. Yeah? And then in line 27, we've dereferenced this value, and it got added to the, so it dereferenced this, which is the dereferencing the address that it's sitting in. So that means go to this address. I've gone to this address. And when I've dereferenced whatever I want to, I'm pointing to it, like you can see my fingers, but you can't. Then I've taken whatever's sitting here, dereferenced the number, and put it into this address. Yeah. Okay? Okay. I know that we're doing something very simple right now, so it's not so clear why do I need a pointer. I can just do this in main in 5 seconds and then we're done. But as code becomes more complex and you need to hold on to a lot more things, you will see the point of it more clearly. I think it's the same with enums. Sometimes it's hard to see the point when you're doing something so simple. Why on earth do I need it? It's when complexity grows that you need all of these different data types and you need all of these different data structures to actually put together something that makes sense. You can remove pointer. You don't need to have pointer. This is just what I call them so that to show that it is a pointer. All you need is just a variable name, right? But I find it easier in my code because I just got used to it when I was working for years and years with that notation. Someone else's style guide, but it's stuck. Okay, excellent. Let's look at something else because you haven't had enough today. I feel like you are just, you could just take so much more. And I feel so bad. It's a very heavy lecture. Has my screen frozen? What's happening? Can you see? Have I frozen? Don't know what's going on. No, you can see that there is a stack on the screen. Can you see that? Okay, you can see. How insane. My YouTube studio is just showing me nothing. Excellent. The colorful ladder. That's how I like to refer to it. Okay, so excellent. So what we have, and we have like 10 minutes to go. I've run out of time again, but we're doing okay actually. I'd rather spend a little bit more time and then we can do it on Monday when we come back and give you a little bit of time to sit with it. So not a bad thing. So far what we've been doing is we've been working in this area of memory called the stack. Okay, what that means is that the memory is allocated at compile time and we don't really control that memory, okay? It's not under our control. And we're growing it like this, okay? So basically, stack memory is where all the relevant information is. So all the function calls are made in the stack, what variables you've created, the spaces given to them on the stack. When the braces close, everything is removed from the stack, right? So it's not, and you saw that when all of those memory addresses changed, it's because our curly brackets closed and our program finished and it all got removed from the stack, okay, automatically. So at compile time, stack is allocated memory space, but not at runtime. So you have very little control. You don't have any control actually. It's not controlled by you. So the stack is controlled at compile time. So I wanted to run through a program just so that you can see how the stack works, okay? And sometimes it helps to understand what you're doing with your variables. It's something, kind of just like a little foundation to give you a little bit of grounding of what's going on. So when we start our main program, the main goes on the stack, okay? The actual function call goes on the stack. So let's say I'm executing this program. Then if I declare my next variable number, that goes on the stack inside the main. Then I call the next thing and I assign something to it. It goes on the stack in the main as well. Similarly for the third variable, again, it goes on the stack and I assign a value -1 to it. The next thing on number 11, you can see we're actually declaring a pointer here and assigning it the address in which this variable is stored. So we are declaring a pointer and we're assigning it the address where this is stored. Again, it just goes on the stack. Now, on line 12, what happens is there is a call to a function made, and the call to the function is sum. So when we do the next thing, remember the right side always goes first. Then when it comes back, it assigns to the left side. So sum will move onto the stack, okay? And it's sitting separate to the main, right? It's another function call. It means that we go into this function now, and inside this function, we now have a number 10, and we add 15, another 5 to that number. So that number 10 then changes to 15, and then the next line returns that number, okay? So what that means is that where we called the sum from, it's going to have the number 15. But when we reach this curly bracket closing, what's going to happen is that is going to be removed from the stack automatically. So all that memory is now cleaned up, okay? And number 4 is now created and assigned that number 15. Now when I move one more over and I get to the curly brackets and I exit this function, the stack is completely cleared, right? So all the memory is deallocated and returned back to the, wonderful place where all memory comes from. So up until now, okay, all we've done, I did want to talk about that, but that's, yeah. Okay, I'm going to just talk about one more thing. What's the time? Oh, I do have time to, okay. So we are going to move into manual memory management a little bit, okay? And that's the memory that you control, okay? So I'm trying to just kind of get to it, but I don't think 5 minutes is enough to explain it. So we're going to start it completely on the Monday after Flex Week. So if we create, so all this memory is allocated at compile time, okay? And all this memory kind of lives and dies between the curly brackets. So let's say we've got this array, we try to return something, but when we close the curly brackets, the whole array is killed, right? So we're returning a pointer to a memory that we no longer have. And we will talk about that in a second. So the memory that you manually manage is the memory that is going on the heap, okay? So what we want to do is we want to allocate memory ourselves as we need it at runtime. And we want to give ourselves the freedom to also manage that memory, okay? And that all happens on the heap. So when you have the heap and the stack, that memory, the stack is not controlled by you, the heap is controlled by you. That means you have to allocate memory and deallocate it. And that's what it means to have memory management, right? Is that you can't just allocate some memory and then never deallocate it, okay? Because 1, you're wasting memory. 2, it's creating security vulnerabilities. 3, a whole range of other issues, right? So the way you use memory is going to also kind of change a little bit. And we're going to just touch on that in this course because we're going to be doing linked lists, which do require you to allocate your own memory. But don't worry, in some ways, I feel that linked lists are actually easier than arrays to understand and manage. So don't worry, we will rehash everything after Flex Week as well. I'm not going to do memory allocation today because there's not enough time and that would just be absolutely mad. And I'm not going to show you that arrays are decaying pointers, or should I? No, there's not enough time. That would be mad as well. I think we should probably 3:55. I've cooked you enough with a lot of material. Don't worry, we will continue on the Monday. I want you to have a restful week, even if you are doing your assignment. And I want you to remember that help sessions are still running during Flex Week, okay? So please come in and see us if you have any problems at all. We will also be closely monitoring the forum. We've got extra people on the forum in Flex Week to make sure that we can answer questions as they come in. There are no classes next week, so no tutorials, no labs, no lectures. You'll have that little bonus of me solving that thing, but that's it. But do please take some time to actually catch up on sleep and stuff like that. Okay, leave me some feedback for what you would like to cover when we come back. What I plan to cover is I plan to rehash the pointers a little bit. I plan to do memory allocation and memory deallocation when we come back. And then I plan to start a whole new beautiful journey to linked lists, okay? That's what I plan to do when we come back after Flex Week. I hope you have a really lovely rest of the week and also really nice next week as well. And if you have any questions, I'm still on this chat, for another, 5-10 minutes. Feel free to ask in the chat as well. Okay, so leave me some thoughts. I love your thoughts. And have a lovely, lovely, lovely Flex Week. Bye, everyone.